Hello, and welcome to Mushroom Mundo. Yeah, right? You think I'm gonna have a cheesy little introduction? I haven't done the YouTubes before. I like hanging out with the mushrooms, but occasionally I like to help people with their projects related to fungi and working with mushrooms also, and that's what I'm doing today. Today we are going to be going over how you do not need to use parafilm to close Petri plates anymore. That's right, there are alternatives and they are affordable. Now, parafilm does have its uses and maybe you will still want to use it for one reason or another, but today I'm going to present to you how you can use plastic wrap, PVC film, saran wrap, whatever you want to call it, to close your Petri plates and so much more in the laboratory. Now, in order to use the plastic wrap, you have to get the plastic wrap. Right, so you can get it online, you can get it at your local store. I'm gonna cut to a video here showing me getting it at the store and throwing it into my cart. You don't want the pre-cut stuff. If you got the pre-cut stuff, you're gonna get to your lab and you're gonna try to use it and realize that's no good. And then you're gonna have to go back and get the stuff that you want, which is just the continuous roll of PVC film, plastic wrap. This is gonna take a lot of editing and this will probably never get published. But I tried, okay? I really did try to help you all, but you're beyond help. What are we gonna do now? We're going to cut the PVC film so that it can function to wrap Petri plates. This is what you're gonna end up with, and if you wanna be really cool, you can end up putting it onto one of these rollers and have an even better experience working with your Petri plates. It's super fast to roll. You don't need to pre-cut parafilm. You just grab your plate when you're finished with it and roll. I'm gonna demonstrate all that for you today. Let's go, let's go. So, we take our PVC film. The first thing that we're gonna want to do is to get it out of the box. Now that you have your PVC film, plastic wrap, saran wrap, brand name, whatever you wanna call it, Kleenex, tissue, one of the easiest ways is to find a hacksaw, and you can simply cut a piece off. But the issue with using a hacksaw is that after you cut it off, you're not gonna have the cleanest edge. And you won't be able to get a clean roll of the plastic coming off. I'll demonstrate on this old roll. You can use a hacksaw to do this. It is not the best tool. The best tool is that pipe cutter. We're gonna get to that next. Using the hacksaw, set it however you want, make it nice and firm, pick your spot, and you're gonna cut back and forth, and you're gonna generate a lot of dust. This is not a good idea to do in your laboratory. So in using the hacksaw, get it pretty fine. And the issue is, as you can probably see, it's generating a lot of dust. I would not suggest doing this in your laboratory in front of your flow hood. It's needless dust and potential contamination down the line. Dust can harbor a lot of small particles like bacteria, fungi, pollen, things that you don't want in the air, because the less material in the air, the less material that can land in your Petri plates, the less microorganisms that will potentially infect what you're trying to isolate. The issue with using a hacksaw is you do not get a very clean cut at the end. And if you try to pull off this PVC film, you'll see that it might work fine or it'll start to run because it's getting caught up on that edge there. So then you need to come in and cut off at an angle that whole edge. This is doable if all you have is a hacksaw and PVC film. This is still worth your time, and it's going to come out to be a lot cheaper than using parafilm. So after you've cut off that whole jagged edge, you should now be left with plastic that can pull off cleanly. Jump right to using this, you can see that you can then have your leading plastic edge, your plate, and press it, and you can wrap around. It's very quick, it's very easy, you don't need to pre-cut anything. You can go around once, you can go around twice, you can go around until you run out of plastic. It's only 30 meters though, so I don't know why you would do that, and it's great. Even better than the hacksaw and not producing any dust, we're going to use a pipe cutter. These are wonderful. The pipe cutter is the recommended tool to prepare your plastic wrap for working with Petri plates. It's really simple. You're going to take your roll of plastic, pipe cutter, put it in, and that is not the thickness that I want, so make sure that you have it at the actual thickness that you want. That looks good enough. And you're going to squeeze over and over again. You might need to give a little bit of pressure to start, and it'll start cutting through. You can see that this jumps to a different notch each time as it starts going through. Generally will not cut all the way through, so you'll have to open it up again. Place it inside, same deal. This gives a very clean and perfect cut. Because it's a smooth blade, you're not running a jagged edge along here, so there's much less chance that you're going to introduce a contamination or a small space of irregularity. And this comes ready to use. You can already start peeling the plastic off. Just a little short there because it's the beginning of the roll. But as you can see, that leading edge, the edge that we just cut, is not having any issue to pull away. So no need to go in afterwards with the scalpel, nothing like that. So now on to the best part. We're going to, instead of just using this by hand to wrap the Petri plates, we're going to use this magically 3D printed tool to hold the plastic in place. You can already see it's in multiple pieces. I'll put the link to the build in the comments, in the caption, YouTube. So this comes apart, and I'm gonna change the angle on this all for you now so that we can have some more fun. Woo. Great, we're going to look at how to put the plastic onto here. I modified this slightly from the file that I'm going to share because I wanted it to look like a mushroom on the top, so I made this and I put it on the top. It's not necessary, but you should fill your world with art because art is fun. I don't know what we're here for if not to make art. So this whole thing unscrews. I've broken it probably multiple times. So there you have it. Those are all the pieces that go into making that, with this not being necessary. And you don't even necessarily need this end cap, but it does help it stand up on its own a bit better. You can get these hexes and threaded rod really easily at any hardware store. And you can even cut this with that hacksaw if you need, but they'll probably cut it for you at your hardware store, or you can find small pieces that serve your use. So what you want to do is put the handle on, and that screws into that, and you can put your base if you want. With the handle. This is going to be the lower stop. And send that all the way to the bottom. So it's a nice snug fit. The pieces that are actually going to be rotating are these, and they are beautifully crafted and tapered to fit multiple width rolls. You can see that they can fit in a wide roll, they fit in a narrow roll, whatever. So this just slides on. Then you're going to take your roll in the orientation that you want it to be. I like it to go this way, I believe. Yeah, so this roll is actually a little too narrow to fit onto here. I guess that's why I use that for other things. This wider one does fit well, but if you are 3D printing it yourself or sending it to be 3D printed, you can change the size to fit the rolls that you have locally available, right? Because I'm going to want to unroll like that. So you can see that that fits in there. And then in this upper one, put that in. And you can already see that it's going to be able to rotate. Put on the upper stop, which also is threaded inherently. And you'll have to experiment for the level of tightness so that it rolls off at the tension that you want. Too tight. That's better. You can put a nut at the top to stop it. I made this cap. I like my cap. Gives a good tension. Now you can see we have magic. So why is this so much better than just having the roll in your hand? Well, when you have the roll in your hand, you're inevitably going to end up touching it too much and you're going to contaminate it, because one way or another, even if your sterile technique is awesome, bacteria, fungi, viruses on other little particles can hitch a ride on your hands and then get onto what you're touching. So the less that you need to touch things that are going to be exposed to your sterile areas, the better. This is fun. I've got a dirty Fehlschweinitz plate that I'm cleaning up here. And you can see how simply you can wrap a plate. So even in line with the flow, you can place it. If you want to, you can wrap your plate without ever exposing your hands to an unwrapped spot so that nothing can tuck into the plate and get into your grow area. Use an old plate of Trametes sanguinea to demonstrate. Pycnoporus sanguineus. Names are always changing, huh? It's pretty easy afterwards also to just, you can take the plastic and just peel it off at any point. So now we have an unwrapped Petri plate. And imagining that we're in our workflow and we want to wrap it, and we just finished it, making a section, whatever. We're going to take that, can set the plastic to connect. And you can walk your fingers along the plate until it's completely wrapped. That's a full wrap. So this is great because when we're wrapping Petri plates, we don't want to have anything between our airflow and our sterile space. And sometimes while messing with Parafilm, it's easy to see that people put their fingers between the Petri plate and the flow hood. And that's a no-go. That's not sterile technique. Just because you're in a flow hood doesn't mean that you can do whatever you want, because bacteria and fungi and other microorganisms on your fingers can be blown off and then land on the plate. So this tool is great for simply putting the plastic on. And if you want, you can just walk your fingers and you keep going until your plate is fully wrapped. You don't need to have your fingers in front of the plastic. The plastic that's being exposed is just in this leading edge right there, so that's keeping you extra clean also. And then your plate stays really nicely closed. And it doesn't matter if you have changes in humidity or temperature. This is not going to crack and open like Parafilm will, but I also am pretty sure that it does not allow a great exchange of gases, which for all intents and purposes really doesn't matter for most Basidiomycete cultivation. Especially if you're only going to have these growing for a week or so, the trapped air that's in there is enough for them to do what they want to do. That's the beauty of the Petri plate. Well, there you have it. One of my first examples of using an innovative tool in the mycological laboratory. I'm sweating in here. I gotta get the AC on. If I had it on, you wouldn't be able to hear what I'm saying. It is hot, so I'm done. You want anything else, you gotta go to the comments and ask me some questions. Oh, frequently asked questions. Do you sell this? No. And if anyone does start selling it, I'm gonna be kind of ashamed of you. Talk to someone that can 3D print this for you and get it for as cheap as possible. I'm gonna drop all the links necessary, all of the instructions. If you need further instructions on how to successfully 3D print it, I will do that. I wanna see you collaborating with people to make awesome tools and grow beautiful fungi. You don't need to buy every little gadget that comes out, but you do need to figure out how to create it with your community, because that's really cool. But if you do want to just buy it, have fun. Someone wants to go out and make this really nice and fancy and try to put a patent on it or whatever. It's a lint roller, okay? It's basically a lint roller. You can probably use a lint roller, but the adjustability of all this is what's making this so nice. Yeah? Okay, we done here? We done here. I'm out. What's up, YouTube? That's right. I am outside because we are not done yet. We know that plastic wrap is going to be cheaper than Parafilm. It's going to be stronger too. Question that we have to answer: is it better for you? And it depends. Like most things, it depends. Gas exchange. It's going to be better with Parafilm and worse with plastic wrap. The plastic wrap is going to give you a complete seal. You're not going to be having the oxygen, carbon dioxide changing out. Mushrooms, Basidiomycetes, Ascomycetes, they take in oxygen and put out CO2. So after enough time, you're going to have an anaerobic Petri plate, which means if you have any contaminants, such as anaerobic organisms, they'll start to grow, and that's not ideal. If your culture technique is perfect and you have a totally isolated organism, then it's not a big deal if you've completely sealed the plate or not. Your growth will be hindered eventually as the oxygen is used up, but in the 7 to 10, maybe 14 days that it takes most mushrooms to colonize a Petri plate, it's not really an issue. A point that I have to give to Parafilm is that it is industry standard. It's lab accepted. There are circumstances where you want the gas exchange. It's extremely useful for many applications, and it's produced at a high production level, so you know that it's coming to you sterile and ready for sterile work, and at a high price point. Whereas the plastic wrap is going to be cheap. You can't look into how well it's produced most of the time, and even though it seems to come sterile to the point that no contaminants are being introduced, there's no industry guarantee. It's not intended for laboratory uses. So what's better? It depends on you. How good is your technique? How cheap do you want to be? And who are you sharing your work with? And what kind of expectations do they have of you? For me, personally, good technique, wanting to save money, I'm gonna go with the plastic wrap. Most of the times, I don't need the breathability of the Parafilm when I'm just running things in Petri plates really quickly. So, there you go. So, is it better? Hop into the comments and let me know. If you've used PVC film before, if you have something to say about Parafilm, something I missed in the video, let's hear it. And if you could like and subscribe to the channel while you're at it, you know that helps this all to grow And a lot more content like this can be put out. Looking to collaborate with absolutely anybody and everybody in the mycological space. It's about the art. It's about you. It's about the mushrooms. Let's go.